What's up, guys? Welcome to the Kyber Cantina. My name is Max. We are at Sable Grove Media. It's where we record all of our podcasts. And we do all sorts of media, so if you need anything, let us know. We will hook you up. As always, I'm here with my engineer, Baby Jamie. What's up, Jamie?
Oh, so I can finally talk now.
Yeah, you can't. So if you haven't checked out our lad podcast, we introduce Apurva, sort of set the stage to talk about the science of Star Wars. So go check that one out first. And if you've already seen that, welcome. Here we go. We're going to get cracking. Apurva, I know what I want to talk about, but what's always more interesting is what you want to talk about. So before I get on my agenda, what do you have for me?
Thank you, Kermit the Frog.
You're
Just
welcome.
kidding. No, I
don't do a
feel
Kermit
like
impression,
we had
so.
it.
Otherwise, I would. What's it sound like?
I just saw that one
I don't
Kermit the
remember.
Frog dancing to that what Dreams by that one band in the 70s. Y'all look it up, remastered
Yeah,
99 edition.
I've committed mass genocide.
Was. Be quiet.
There you go. And Kermit's just dancing. It says like day 9 of quarantine. Anyways, meme stuff. No, but that's not. I don't always have more interesting things to say. Sometimes I just talk about random shit, as all of us. But one thing I did want to say is that last time we had this awesome podcast, and y'all were getting to know the personality. And so like this one, we can like focus more on the physics and the math, and I think it'll be really interesting in talking about astrophysics. And so what I wanted to say,
down.
yeah, you asked me a really good question. You were like, dude, what does a billion Gauss mean in energy?
Yeah. We were talking about those stars that had gone through supernova and had a huge electrical magnetic field.
Pulsars.
Pulsar.
Yeah. The best atomic clocks in the universe. Most stable. And so like a billion Gauss. So like 1 Gauss corresponds to the magnetic flux density that will induce an electromotive force of 1 abvolt, they say, which is like fucking 10 nanovolts. It's nothing.
Okay.
So a Gauss is like what we got around at Earth, a little more, maybe like 10 Gauss at Jupiter. But at this exoplanet system, the PSR 1257b12, I always fuck up the phone number, but but that one's right, that number. It's actually a billion Gauss. And so that means that how many volts there are is a shit ton, which is 10 volts. 10 volts.
Yeah, by a billion.
Yeah, and
Right.
get this, 10 volts per billion Gauss in each linear centimeter of a wire moving laterally at 1 centimeter per second at right angles to a magnetic flux. And that's why electromagnetics is complicated.
Okay. Yeah, so you can take magnetics and make some type of transfer through to electricity to make a comparison, I guess, with energy. But it's honestly still, it's like so much energy, I can't comprehend it. Like,
Yeah,
I don't know the math to do it.
It's a lot for a linear, like a centimeter. A tiny centimeter having 10 volts, that's a lot. Think of your like 120 volt socket. That's like it's
I
holding
gotcha.
giant machines. that are many centimeters wide.
That's a good comparison.
I mean, my advisor was a PhD in plasma physics, but I am not. So I'm just trying out here, trying as a humble astronomer. But yeah, one thing Baby J was talking about was consciousness. And that's one thing we could get into, talking about the is it called mitochondria?
Midichlorians.
The powerhouse of the cell?
Yeah, the mitochondria.
Of the force?
Yeah, and then midichlorians.
Yeah, and I think it has to do with an earlier conversation we were having about like how the brain emits alpha waves. And interestingly, I got the numbers right here in front of you. Well, Jamie, you think you can pull it up right quick?
I got you.
Yo,
Okay.
boy, just pull it up, dude.
Yeah. So what's the... Oh, shit. Yeah, thanks, Jamie. Dude, the magnetic field of the human brain is a nanogauss.
A nano, guys. Oh, yeah, okay.
That's nothing. And so like 100 Gauss is an iron magnet. The Earth's magnetic field at its core is 25 Gauss, so that you're down there. You probably should have gotten it by now. But 3,000 or 70,000 Gauss is a medical magnetic resonance imaging machine, MRI.
Okay.
Which, you gotta wear your protective covering or else yeah.
Radiation.
Yep. And then so a trillion Gauss is usually the surface of a regular neutron star, but these millisecond pulsars are a little weaker and no one really knows why. It seems to be a mystery.
So far.
And so, like, to kick things off, I was going to say that in Star Wars, there are no planets that orbit pulsars. They have this universe that's kind of Swiss in the sense that they got habitable zones, they got, like, desert worlds. They're all in a nice, safe place, but who's to say those people, like fucking Anakin, can't build some plasma ship and then live on some crazy world? Maybe he terraforms it. And so that's why, going back to last week's podcast on the universe, that talk I gave, I think that was to get people to think out of their comfort zones. Because habitability is what makes us comfortable.
Yeah, talking about stuff that's outside of the habitable zone. So I have a question about Kepler. Was it
16b?
16b. It's like Tatooine, and it's like the planet Namek. It has multiple stars around it.
Yeah, multiple
So
suns.
like we don't have visual aids here necessarily, but explain how you can have a planet that can be habitable with multiple stars. How do they work in space?
Yeah, so in the Dragon Ball Z universe,
Namek. Is that two? That's two suns.
3 suns.
That's 3. Okay.
And it's always day there. And the catch of the series is, once again, spoiler alert, Dragon Ball Z. Please tune out the next minute if you haven't seen it. The point is, the Saiyans are fucking crazy lunar monkeys.
Yeah.
And if they see any light, like powerful light from a moonbeam, like a midnight moon, they go full on werewolf, and they go monkey wolf.
Yeah. With their tails and everything, yeah.
Super Saiyan 5 or some shit. Like their power level is so high, but they get really
their
tired.
Hair is so long. Like, what product do Zayd's use that their hair looks so amazing?
Maybe like argan oil from Morocco.
Well, I don't know. You're more cultured than me.
That is not applicable to me.
Okay.
Maybe.
So.
Wait, but the Saiyans, if there's 3 suns in the sky, it's always daylight. And the thing is, if it goes dark, then they'll go nuts. So Namek is a place where Frieza wants his or her Saiyans. I mean, in the first version of Dragon Ball Z, Frieza definitely looked like a woman. It was definitely a guy. Maybe Frieza's gender neutral.
Yeah.
Or trans. I don't know.
mean, Frieza's an alien, so they don't play by our rules.
He or she or they do what they want.
Right. Clearly. Destroying planets with their pointer finger.
Yeah. It's just evil. Like, at least use like fucking Kamehameha. Plasma wave.
Oh.
So that's why in Dragon Ball Z that
I don't know if deciding how to destroy a planet is more or less evil than another way.
Yeah, I guess that's I just like volcanoes. The Ios we were talking about, like when they explode, they become like Mustafar.
Yeah, Mustafar. Right.
Yeah.
That's where Vader gets all chopped up and stuff. Talk to me about Mustafar. We're on Mustafar.
I have the high ground, Anakin. I have the high ground.
Yeah, Darth Maul had the high ground too. That didn't turn out the way I thought. And Vader does get the high ground at some point, finally. But he gets electrocuted in that story because he's the highest thing up.
Yeah, remember like 1977, A New Hope?
I wasn't there.
When, hey, remember New Hope? Yeah, I remember.
Remember Chewbacca?
Oh, yeah, I remember.
So how would these 3 stars be moving around the planet? Is that the only way? Like the planet would be in the middle?
Orbits the stars.
All 3 of them.
Well, I don't know if there's a confirmed system like that in exoplanets. Maybe you have. There is.
Like how does it work? How would that even work? Whether it's real or not?
Would orbit a tight binary, and then the star would be far away outside that planet's orbit. So it's technically the planet of the binary star system, and the third
and then the
star.
third one's just out there, really
This-
close.
Yeah, but that's not Namek. Namek has all three in the center, I think.
How? So it's not real. Namek's not a real planet.
Well, think about it this way. We just don't know. Like Proxima Centauri is the closest star to Earth.
Okay.
It's about 3.6 light years away.
It takes 3.6 years to get there, traveling at the speed of light.
For a photon.
Yeah, and you refer to that as not that far away.
That's real close.
Okay.
In astronomy distances.
Yeah.
Planetary distances, that's pretty far. We need to make a warp drive.
Okay.
Yeah. So, that's a good question. I mean,
the question really is Namek and its physics real?
yeah. So I was gonna say that Proxima Centauri, Alpha Centauri, and Alpha Centauri B, they're real stars, and they could have planets, but we just don't know if there's a Namek there. Our telescopes aren't sensitive enough. Our instruments aren't stable enough to detect that.
Yeah.
There is a planet, Proxima Centauri B, that's got, I think it's in the habitable zone, and it's real brilliant. I got a friend actually, Gavin Coleman. He's from Kent. It's a little bit outside London, so it's not really Cockney per se, but maybe he thinks he's Cockney, taking the pairs instead of the stairs, But that kind of planet is consistent with planet Namek.
Okay.
Right, so
and
it
then,
could be.
But then Tatooine. So you already explained how Tatooine is in a binary star system.
But sorry, going back to Namek, it'd have to orbit all three stars. Do you see? It has to go around the whole thing. If we're putting up a visual here in this podcast, we're showing the planet orbiting three stars in the center. Yeah, and then Tatooine has two stars that it orbits, and it's a red dwarf and like a sun-like star.
Oh yeah.
So Kepler 16b. Pretty close, and I don't know if there's a desert on Kepler 16b.
And there is night on Tatooine though, right? Like, are these? Explain how a planet would move around a binary star system.
Well,
binary star is two stars that are rotating around each other, right?
Right, but is there Bud Light on these planets or not? Are they in the habitable zone? The zone where beer is a liquid?
Well, let's assume, these are planets in a habitable zone, so they're drinking alcohol out there in space.
Which is a little farther out.
Shit.
That zone's a little farther out. Like Mars is in the habitable zone.
Really? Mm-hmm. Oh, okay.
You should check out this paper. It's by King, 2016, I think, maybe 2017. King 2017. There's a guy named MC Schoof in there, Haze Cube, Eccentric D. Many people. But that paper calculates the habitable zone, the zone away from, actually does the calculation, the full one, where beer, like Bud Light, Platinum, is just liquid. Naturally, if there's alcohol in these plants, they desorb after they form, and maybe there's alcohol molecules like, C6H5OH, the formula for ethanol.
Yeah.
If that shit's there, it's gonna be liquid there. 5% of that, 95% water. Beer.
It's 5% alcohol.
It's a habitable zone. Man, drink a limoncello to that.
Yeah. Cheers, man.
Cheers, Mike.
Yeah.
Cheers, Jamie.
Okay. Aren't a warp drive and a hyperdrive the same thing?
Yeah, dude. Yeah.
How do these work to get people from place to place through space?
That is one of the biggest, I'd say, practical considerations of modern physics. And when I say practical, I'm saying, can we travel to other star systems within our lifetime?
Yeah.
You said it'll take 3.6 years to get there.
Moving as fast as a photon.
As photon, which, that defies a lot of physics to do that.
Right.
You're using an infinite amount of energy if you get to C, because E equals mc squared and all that jazz. But the thing is, if you leave the Earth at escape velocity and then you start floating out near Saturn, at Saturn you decide to activate the warp drive, what this means is this hyperdrive in the Millennium Falcon will take a small region of space around you and harness the dark energy that's embedded in the space-time continuum, and it will convert that just into speed. because things cannot move faster than the speed of light. Information cannot travel faster than the speed of light, but space can.
Okay. So they changed space around it using dark energy from dark matter.
No, nothing to do with dark matter. Dark energy has always been separate and different.
How's it different?
Well, that's the thing. Dark matter is like matter. I could have a dark matter microphone sitting in front of me with a dark matter Ticonderoga No. 2 pencil.
Yeah.
That's made of dark matter, pure. It's just sitting in the universe that has a dark energy component in it, like in the vacuum itself. 100% dark energy universe requires nothing in it. It don't need no mics. It don't need no noobs. It don't need no Ozas. It's just Baby J and his space of dark energy. Does that make sense?
Kind of. You're saying there's like a dark matter universe.
No, dark energy universe.
Okay, and in that universe, the matter there is dark matter.
No, not really. Like,
okay.
I'm just saying, like, you don't need to have. That's a good question because it is kind of confusing. Like, dark matter, we think it's just a particle that doesn't interact with the electromagnetic force, so you can't see it, right? That's visible light. Photons do, matter does, but not dark matter. But dark energy is a whole different wavelength. That could just be, you put dark matter, you have to put dark matter in something, right?
I guess. Yeah, it's matter.
Yeah, you have to put the matter in, like, imagine in a vessel, and that vessel is dark energy that's carrying the team on its back. Oh my God.
So what's comparable then from dark? If you have dark matter, and you have dark energy, the comparison there's energy, potential energy.
Yeah, because it's all
energy.
mass energy. Yeah, you can convert all the dark matter into energy, or even dark energy. Maybe, who knows? We don't really know what it is to say such claims, but that's the thing. And when I was in government school, like back in Winston-Salem, I always just loved Salem's College. So I give a shout out to North Carolina for that. There was all these amazing like topology talks and crazy multiverse talks, and we were like 16. And at that time, a cosmologist gave a talk and told us that the universe is 73% dark energy and 23% Michael Jordan dark matter. But those were the numbers at the time, and we were just 4%. Turns out we're still, I think, roughly 4%, but there's more dark matter than we thought and less dark energy.
Okay.
So it's like 70% dark energy, 26% dark matter.
Yeah, and it would be naive to think that there isn't something going on with more than 90% of like the universe. You're saying 4% is simply what's tangible to us.
That's it. Yeah, it's kind of nice spiritually thinking, you know?
Mm-hmm.
That's right. I have a PhD in astrophysics, and I dare to talk about spirituality.
I have a question about explosions.
Oh, hell yeah. This is what I like. Stellar explosions, planetary explosions, hit me.
Okay. Different kind of explosions. The question is, how can explosions exist on such a huge scale, like in Star Wars, without enough of the necessary chemicals / gases in space to create an explosion like that? Somebody on Twitter asked us that. I was like, hey, an astrophysicist is coming. They were like, okay, well, I want to know how these explosions happen in space.
Yeah. That's a great question, because, like, we always talk about...
It's just poking, like, is the physics of Star Wars real there, or is it silly?
Well, it's like, you know, that thing where there's, like, no sound in space, but they do make sound in Star Wars.
Yes.
Explosions. That, I think, is artificial, or you have to have some contrived way to make it work, you know? But the explosion itself just requires combustion, right? You just need a high enough density of molecular oxygen to interact with some carbon. Like, you know, when you light your J outside, or you light your neighbor's house on fire. I don't know what Homer Simpson does, but
whatever it is.
You gotta light something, and that's really, you're getting that molecular oxygen to combust. And with plant matter, right? So So the thing, what it comes down to, the density of molecular oxygen will dictate its pressure. The column density of a gas is equivalent to the vapor pressure over the force due to gravity. And that's it. So my point is that the pressurized cabins may have enough pressure, like O2, artificial or natural, that it will interact with some other like missile that's coming. It hits, it penetrates the shield, it goes inside. Oh fuck, there's O2 and bam.
Yeah, and then there's explosions. You'd have to really be aiming at the cockpits. And then the Death Star explosion has plenty of oxygen in there. Yeah, that's interesting. I guess I don't know how the Death Star 2 really worked. As far as, ray shielding. They ray shield all that while they're working on it. Yeah, so that's really neat. That's interesting. I didn't think about that. But I wasn't sure if there would be enough oxygen. And it's not how much so much as how pressurized that oxygen is. So I would assume the atmospheric pressure inside those ships is the same as it would be on Earth, for example, or like Corellia is a planet in Star Wars that's like just like Earth. And that would be enough pressure because we have fire here. Sound logic?
Yeah. Sorry, I was looking up what I'm not me. I mean, Jamie, can you look up formula for binding energy? No, I think it goes as GM squared. That would be way too physicsy for this. But I was gonna say that the binding energy of a planet is still tremendous.
The binding energy.
Yeah. So to really destroy a planet, there is a hard limit. Sometimes that energy will
because the Death Star is a planet killer, right? And it blows these planets up instantly.
Yeah, and it has to surpass the binding energy of the planet. Yeah.
So how much energy, in terms I could possibly understand, would it take to explode a planet like that? Like it's made of nothing, like it's made of glass.
Dude, we should definitely talk about that next time.
So you can do the math.
Yes, but also put it in tangible words. Like I think if I said a gamma ray burst has energy of 10 to the 47 joules, would that make sense?
No.
It's just so tremendously
You'd have to be
large.
like, it takes this much to microwave a hot dog for 60 seconds. How many hot dogs and how long? You know?
Yeah.
Like if the Death Star explodes, then it's like, okay, we have one hot dog and it's this much energy.
Well, think like
how many hot dogs of energy goes into that hot dog? You know what I mean? Like that's
yeah.
all I have.
Oh, I got you.
Yeah, it has to be in terms I can understand.
Mustard.
Yeah. Or like it takes this much energy to cook a turkey on Thanksgiving over this much time.
Yeehaw!
So, you know, how much time would it take to cook this many turkeys? Or how many turkeys would it take to blow up a planet this fast? Like, yeah.
For sure. I think it would, like eating one hot dog, you're using like a joule of energy. And so like...
It's like, yeah, exactly. Yeah. How many hot dogs is it at once?
Yeah.
Could a giant do it? And how big would that giant have to be? There's all kinds of questions. Because you can take the volume of a hot dog in relation to a human and figure out how many hot dogs it is and then scale up the giant the same way.
Yeah. Actually, Jamie, why don't you just do the calculation on the back of your envelope? Like, don't you have like Wolfram Alpha? I saw, dude. Yeah, so if you put binding energy of the Earth, oh man, you're a really fast typer, Jamie. Like your skills are impeccable. Yeah, pretty wild. So turns out that it's 2.242 times 10 to the 32 joules. Damn, Jamie, you good. So that's 32 orders of magnitude of energy that you use like every day.
Okay.
So like, what is that? Like, I mean, a trillion, billion.
Yeah. It's 32. When you say that, it's just, it's 32 zeros after the number.
That's right.
So how does the force work in physics? How do you think it works?
That's a great question. I mean, that's probably something I've been thinking about since 1982, you know. But I was going to say Empire Strikes Back and Return of the Jedi and Voyager 1 and 2 are flying by Jupiter and Saturn. The Force, like, it's crazy. It says that inside us we have these particles, or the field, the nature itself has some force-carrying particle that we are able to govern or manipulate or access is the better word, interact with. And it seems that, in the later Star Wars, you see like meditation, closing your eyes, feeling the Force. It's always been a sort of Buddhist analogy.
Yeah, Taoist,
and you can use the Force by just closing your eyes and meditating on it. And how's that going to do anything? Well, you need to see it in that state and then move it. And the implication is that in the Star Wars universe, when you're moving this through your meditative thoughts, you're actually moving objects as well, because it's so powerful. There's no such evidence in our lifetimes of that, but in ancient literature, as you know, maybe mythology, they also say like, beings could do these kind of mystical things.
Right.
Which is really funny. Maybe it's humanity trying to
explain, but there are always those people that look at ancient myth and are like, look at this carefully. Eric Von Daniken, dude, the Charity of the Gods guy.
I don't know, but yeah.
But there is something there. Indians have always maintained, especially, like, look deeper in our myths. There's something there. Like, these were spaceships, these were aliens, things like that.
Kya baat hai, puttar? Kya baat hai?
I wanted to ask you about how Kepler 16b, which is basically Tatooine, how that planet was made. Because there's a story in Star Wars for how Tatooine was made. And most likely it's different than how Kepler 16b, like how Tatooine would actually exist physically. So you tell me the story of Kepler 16b, and I will tell you the story of Tatooine.
Oh, I really like this. This is the nice exchange portion of the podcast. So Kepler 16b, I don't know its whole story, but I can give you a general description of.
Yeah, like how physically these planets get made.
Yeah, you're a molecular cloud floating in free space, mostly hydrogen and helium, the two most abundant elements in the universe, 75% and 25% respectively. You're hanging on this cloud and you got dust, little grains. At some point, the cloud is going to collapse and it's going to start rotating because the thermal pressure, it's so cold out in space, like 10 Kelvin, like negative, 263 degrees Celsius.
That's as close to absolute zero as you could get without actually getting to absolute zero.
0.15, yeah. And the cosmic microwave background of space is like 3 Kelvin.
CMBR.
Yeah,
we were talking about that on WandaVision right now.
Yep,
CMBR,
Beautiful.
See, that sounds smart. Thanks a lot, Darcy.
He is. Max is one of the greatest drummers. Got to be brilliant to be a good drummer.
Count every day.
I was gonna say that. So what happens with these grains? They start conglomerating. They start getting together in the rotating disk of the star, and they start building the first planetary cores. The embryos. The sun itself is an embryo. It's just starting to ignite, starting to fuse. Hydrogen fusion. A literal hydrogen atom meeting another hydrogen atom, saying, "Hey, hello, how are you?" He's like, "I'm good. Do you want to become deuterium?" And then they combine and become deuterium. Then deuterium unites, makes helium, makes alpha particles, helium-4. All this is going to power the Kepler 16 system. And the Kepler 16 system might have companions. I'd have to look it up. But Kepler 16b seems to be... Oh, this is about to drop. There are 2 stars. And we don't know their origins, but maybe they formed in the same cloud. Maybe there was 2 separate clouds that interacted.
You said this is just about to drop?
Yeah, dropping that. I forgot that Kepler 16 was a double star system. In fact, the state-of-the-art simulations in astrophysics don't make planets around double stars.
Really?
Not yet.
When you say just about to drop, like any day now, like the world for the most part is going to know about this?
Oh, I was going to say just about to drop like on the podcast. Like,
okay. I was like, what?
Got everybody listening now. Like, gonna drop like, yo.
I thought it was a moment from the interview, man.
Double star system.
Eminem's on there.
Accreting on and making a disk sort of still there. The gas will last maybe like 3 million years, 10 million years. And that gas will start accreting. Like, accreting is a fancy word of saying like accumulating. Due to gravity there. The gas will last maybe like 3 million years, 10 million years. And that gas will start accreting. Like, accreting is a fancy word of saying like accumulating due to gravity. Accreting on and making a disk sort of due to gravity. Accreting on and making a disk sort of thing around a planet. And this planet we'll get an atmosphere. And it might be hydrogen helium, but then that hydrogen helium will probably escape because Kepler 16b's gravity is so small. But then it could get another atmosphere from its surface. Its surface could be molten, and whatever lava was on Kepler 16b outgassed and made this Tatooine-like desert world. Atmosphere. Everything's volcanic. When you get there, all the volcanoes are gone, all the water's gone. It's a desert land. It's like Mars. Tatooine's like Mars. It's a slave world, right? That's where Anakin's from, right?
Yeah, he's a slave on the I almost said Outer Banks because we're in North Carolina.
Outer Rims.
Yeah, the Outer Rim.
Yeah, man.
Outer Rim territories. The Hutts control that territory.
It reminds me of Kevlar heads, the rim shots.
The drum heads? Yeah, most people don't know. Marching bands use drum heads made out of bulletproof material.
Yeah. We ain't never scared. But we used to do like gunshot noises with rim shots out in the back.
Yeah.
A lot.
We weren't in Greenville. We were in Wakefield. It was cool.
That's right.
I do want to tell you the story of Tatooine before we wrap up. So essentially, this ancient race of people called the Rakatans first figured out how to use the Force, and they even powered their ships using the Force and made what's called the Infinite Empire. This was well before some species had even evolved. They had taken over the galaxy basically already. And the Sith, not the Sith, the Infinite Rakatan Empire eventually destroys this beautiful green lush world, which was Tatooine. They raze it to the ground with their plasma weapons, which is why I was asking you, like, how much energy does it take to destroy a planet, or what about, just raising the surface?
10 to the 32 joules, we calculated.
Yeah.
Or James did.
The planet became glass. And these creatures, like the people that were there, humanoids, went underground. So after, I don't know what you would say, millions, billions of years, all the glass broke down, and that's where the sand is. So these creatures came up, and one of them was the Sand People, the Tusken Raiders, and the other ones were the Jawas. They like evolved kind of different under the sand, and then came out onto the surface. So that's how Tatooine happened. So knowing that information, of course, it was like more like Earth, and then it was destroyed. Like, that's why I was confident that story wouldn't be the same. But yeah,
but it was like Earth, huh?
Yeah.
So no, that's possible. So I'm saying that it's a mystery of how it got, let's say, it became a desert world. Now, what I think NASA and many other organizations, many people, honestly, astronomers or planetary scientists included, say the tale of Mars like it's Earth. It was a Earth with maybe even life on it, with oceans, and there is evidence of that water. But it's all evaporated. Now there's just the frozen stuff on the poles.
Right.
And it's tough to access and break down. But they sell that tale to, I'd say, capitalist investors that decide to sort of, let's just do what we know how to do it. We know how to get there. Let's keep going. And they keep pulling them along, stringing along the investors by telling them there used to be life there,
Yeah.
Well, let's see that life. I mean, we've been there since Viking 1 in like 1972 or some shit, maybe 1960. And I'm saying that, the moon could have had life. It's not as exciting, but if Mars has life, why doesn't the moon?
Right.
Why doesn't Venus's clouds have life? Why don't Mercury's, polar water caps have life? So the whole thing about Tatooine is, it's a lesson that the way they destroy it is just a desert world. That's what Mars is today. We have to live in the present. And Mars has no life at present, has no liquid water. It's desiccated. Desiccated means to remove all the water from a body.
Right.
And so that's Tatooine as well.
Oh.
It's people are thirsty there. People are
they
poor
farm
there.
for moisture, right?
Yeah, it's rough, man.
Well, this has been amazing, dude. I really appreciate you coming on. We're going to have Apurva for more science and more Star Wars, maybe the physics of superheroes, things like that.
Mustafar and Mercury.
Yeah. And we'll talk about Mustafar. We're going to talk about Mercury, because these are like planets that he researches. But thanks for being here, man. I really appreciate you.
Yo, thanks for having me here.
I do want to give a shout out to this guy, Aqua Snoopy 7. He's the one who does all of our video game footage, and you can check out what's going on with Apurva at apurvaoza.com.
Oza.
And I hope you enjoyed. We'll see you next time. Until our paths cross.
Shukriya. I saw, dude. Yo, be sure to, I guess, like it if you like it. Comment if you got something to say. Follow Kyber Cantina, because we're going to get in the center of lightsabers and talk about photonics, astro. Yeah.